Chapter 2 Number System and Codes. Okay, first let's talk about number system that we usually use. Okay, the number system that we usually use is called positional number system. Okay, which represented by a string of digits. Okay, where each digit the person has an associated weight. The value of the number is weight sum of digits. For example, this number 4,321. Okay, you can write that 4,310,1. Okay, the digit. Okay, the weight of the digit is 1, 10, 100, and 1,000. Or can you write it as 10 to the power of 0, 1 to the power of 1, 2 to the power of 2, 3 to the power of 3. So it is base, right? Base, okay? Base 10. Okay? And the power, okay? We change with the position of the digit. At the digit, first digit, this one, 10 to the power of 0. The next digit to the power of 1, the next digit to the power of 2, and so on. But how about this? 987.654. Again, for this one, the weight for this position is 100, or 10 to the power of 2. The digit 10 to the power of 1, the digit 10 to the power of 0. And for this digit, 10 to the power of minus 1, 10 to the power of minus 2, 10 to the power of minus 3. Okay, and okay, let I call this as coefficient. Okay, this coefficient for this position for each digit, the number that can be for each digit is for Radix 10 or base 10 number. It can be 0, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, just 0 to 9. Okay, 10 number that can be for each position or each digit. This point is very important. This digit it cannot be 10, right? It cannot be 11 or the number that greater than 9. Okay? And it should be integer. Okay, now how about Radix 4? Radix 4, for example, something Radix 4. Of course, you can write that as, for example, the digit is, right? Multiply 4 to the power of 0 plus the digits multiply 4 to the power of 1, the digit multiply 4 to the power of 2, okay, and add them together. Then you will obtain the value, okay, of this number and refer to the base 10 or Radix 10 number. And for Radix 4, each position or each digit, the number that can be in each digit is 0, 1, 2, and 3. Each digit, the number can be 0, 1, 2, and 3. It cannot be 4, it cannot be 5. Okay, so it's very important. Okay, now let's see something in general. Okay, maybe we can you can write it as the digit D. Okay, and the next one it refer at this point, Radix point. This is D0, D1, and so on. And this person is called MSD, most significant digit that have the maximum weight, okay, for that number. And this one is the least significant digit, okay, lowest, okay, lowest number, lowest weight number. Okay, then if you want to know the value for radix or base R, you just write it down in this form, namely this digit, you treat it as coefficient that multiply with radix number R raised to the power of p minus 1 plus the next value, okay, until out of coefficient used. So we obtain the final result of the value in base 10 number, in decimal value. For example, if you would like to know the value of 3, 2, 1 radix 4, you just write in this pattern, right? Okay, that is 1 multiply 4 to the power of 0 plus 2 multiply 4 to the power of 1 plus 3 multiply 4 to the power of 2. This coefficient is come from the number for each digit, and then you just sum and calculate. Then you will know the value in decimal number. For example, this one is 1, right? 4 to 8, right? 4 to the power of 2, 16 multiply 3, then sum them together. Then it should be what? 8 and 48 plus 8 plus 1, then it become what? 57 maybe, right? 57 is the value of this 3, 2, 1 radix 4. The result is based on radix tens or decimal value. Okay, how about this one? 1, 0, 1, 1, 0. Base 2. Base 2 or binary number that often used in digital system. Okay, do you know this value? Again, just write down this number, multiply base, right? Base 2 to the power of 0 for this first digit, and the next one, it is 1, 1 multiply to the power of 1 plus the digit 1 multiply to the power of 2 and the digit 0. right? Multiply 2 to the power of 3 plus this one 1 multiply 2 to the power of 4, right? This one, okay, is 0. Okay, for this 1 0 1 1 0 is come from the number for each digit. Then you can calculate the value in decimal form. Namely, for this one is 0, right? 0. At first, let I write the weight for each position. It's 1, right? It's 2. This is 4. This is 8, right? And this one is 16. So for base 2, again, each digit or each position, the number that it can be for each digit is either 0 or 1, right? Okay, for base 2. So if the digit is 1, that means the result of this position is weight for this position. But if the digit number at the digit is 0, 0 multiply some number, the result is 0. That means in binary it's very easy. If you can remember the weight value for each digit or each position, you just some weight for the position that have 1, has number 1. For example, this one, 1 at here, right? 1 at here, so 16, and this position 4, right? And this one 2. Then you sum them together, and the result is 16 plus 4 plus 2. Then it become 22. That's all. It's very easy for binary number. Okay, that means you just remember. So you just remember the weight for each position in binary. Namely, and the first digit is 0, right? Weight, and the next one is weight for the first one to the power of 0 or 1, right? And the next to the power of 1 or 2. The next digit to the power of 2 is 4, right? And so on. 8, 16, 32. That means if you want, for example, want to write down 30 in decimal. If you want to convert to Radix to a binary number, what should you do? You may think something like this. 13 is 16 plus what? Plus 4, right? Okay, 16 plus 4. That means you can write this one as what? 1, 2, 4, 8, 16. Okay, it's 16 at here and 4 at here. Should be 1, 1. Okay, another digits, it should be 0, 0. Okay, that's all. Okay, for example, this one 1011.01. So you can calculate the value in decimal by multiply each number for each digit by its weight, okay, to the power of something, okay, based on the position. For the example, 1, okay, let us start from this point, okay, this one is okay, weight is 1 to the power of 0, and the next digit is this one, and for this one is 0, okay, 0 at here and 1 at here, okay, and this number, okay, behind this point, so it's power of -2, and this one is minus, sorry, this one is -1 and this one is -2, okay, So we can calculate this number. And MSB, LSB, you should know these two words. MSB is from most significant bit, okay, and LSB is least significant bit, okay. The bit that have the maximum weight in the string of digit is called most significant bit. Okay, bit from is from binary digit, and for this position it's called least significant bit. Okay, the lowest weight, okay, in the string of the digit. Okay, and for the positional number system, the most often used is decimal. Okay, and the next one may be binary, okay, in digital circuit or in computer system. Anyway, if you write down in binary number, it's very long string and have just only 1, 1, 0, 0, and so on. Okay, very easy. Okay, and easy to confuse when you write down very long. So to make it shorten, we often write in octal or hexadecimal form. For octal or Radix 8, for example, for Radix 8, Radix 8, that means each digit. The number in each digit can be what? Can be 0, right? 1, 2, 3, 4, 5, 6, 7, 7, right? 0 to 7, 8, no. Okay, it cannot be generally 0 to 7 for each digit. And how about hexadecimal? About hexadecimal, hexadecimal or Radix 16. What about this? The number in this digit, it can be, of course, 0 to 15. For example, if you write down something like this, 2, 1, 1, can you calculate the value? Yes, you can, right? You can write it as 2 multiply 16 to the power of 0 plus what? 1 multiply 16 to the power of 1 plus 1 multiply 16 to the power of 2, right? Then you can calculate the value. And how about this one? How about this one? 1 at here, 4 at here, Radix 16. Okay, the value is 12, right? Multiply 16 to the power of 0 plus 1 multiply 16 to the power of 1. Okay, and how about this one? If you write as 1, 1, 2 Radix 15, of course it cannot be this one, right? It's gonna be 112 Radix 15. Someone maybe create this one. It's possible, right? And it's maybe this one, okay? Or like this one, also possible. So it's quite ambiguous. So to avoid this problem, okay, some people may write something like this, right? But it's not convenient. So for example, for this one, okay, if you want to write 1 and 12, you cannot write this, okay, because it's very confused. So what should you do? So let me change the symbol for the number that have 2 digits. Namely, for 10, 11, 12, 13, 14, and 15, right? So let we use alphabet A, B, C, D, E, and F instead. Okay. So for Radix 16 or hexadecimal, we use A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. Okay. Then, if you use this one, you can write binary in compact form with hexadecimal form. Okay. Next, now if I want to convert, before that, some technical term that you should know, maybe already know. Okay, the first one is bit, right? Bit is a binary digit. Okay, bit. Each position or each digit in binary number is called bit, and a group of 4 bit is called nibble, and 8 bit is 1 byte, 16 bit is 1 word, and 32 bit is double word. Okay. And now how to convert radix r, okay, any radix r to decimal number. It's very easy by using this form. Namely, you just, for example, this one, you just consider the number in a digit as coefficient, multiply radix to the power of something, okay, based on the position. For example, this one is 8, right? 8 multiply 9 to the power of 0 is 4. 4 multiply 9 to the power of 1. 5 multiply to the power of 2. 2 multiply 9 to the number of 3. Okay, and then you can find this decimal value. And how about this one? For 0 point something, okay, number less than 1. Okay, easy, right? Just consider this one, 2 to the power of minus, right? Now for this one is base 4, right? Then 4 to the power of minus 1. 1 multiply 4 to the power of minus 2, and 3 multiply 4 to the number of to the power of minus 3, and sum all of these value. Then you will get a value in decimal. Okay. Okay. It's easy way to convert any radix r number to decimal value. And now, if you want to convert decimal to radix r, what should you do? It's very easy. If you can write down in this form, namely some coefficient multiply r to the power of something, right? Some number multiply r to the power of something. Okay, so if you can arrange the number by this number in the digit, can be 0, 1, 2, and so on until r minus 1. So you just bring this coefficient right, okay, right continuously. So then you can write that number in radix r. Okay. For example, let's see. For example, let's consider this one. 227. Okay. Radix 10 decimal. I want to convert to radix 4. What should I do? At first, you must write this number in this form. Namely, for example, 4 to the power of, for example, multiply 4 to the power of 2 plus 4 to the power of 1 plus 4 to the power of 0. If you can find out the value, okay, for each position as coefficient that multiply 4 to the power of something, and this number, because it's radix 4, right, it can be 0, 1, 2, and 3. That means if you can write this one, that means your answer is this coefficient, right? Just bring the 3 each and write them together, so you can write down radix 4 number completely. Okay, this is the objective that you should do. So for the detail, what can I do? For example, for 227, it's equal to 56 multiplied 4 plus 3, right? And for this one, if you treat this one as coefficient, that means it's 56 multiplied 4 to the power of 1, and the 3 is multiplied 4 to the power of 0, right? This 3 is okay, right? Because it's less than 4, okay? 0, 1, 2, 3. But this one is not okay. So what should you do? You should rearrange this number, right? For example, because 56 is 14 multiplied 4 plus 0. Okay, so from now, then you can write it as something like this, right? And this 4, when you multiply out, so it become what? 0 multiplied 4 to the power of 1, right? And this one is 4 to the power of 2, so it becomes this one. Okay, for this step, then this coefficient is okay, right? This one also okay, right? But this one still be not okay. So what should you do? Again, to change this one only, right? 14 is 3 to the power of 4 plus 2. After that, just multiply out. So then it's become what? It become 2 to the power of 2, right? And 3 to the 3 multiplied 4 to the power of 3. Then become this. And how about this one? This coefficient, this coefficient, this coefficient, and this coefficient is okay, all right? Because it's less than 4. So now you just bring this coefficient, okay, right down together, okay, in compact form. So now you can write, or you can convert this decimal value to radix 4 value. Finish. Okay, easy, right? Just rearrange and convert in this form. Then you can complete this one. By the way, it's easy, right? But it's quite long, okay, to do the calculation or write a lot. So if you observe that the answer, for example, this one is from what? It's from the remainder, right? Remainder from this number divided by 4 divided by radix number. So that means you can find out this remainder by using successive division by Radix. For example, start from this one, right? And divide it by Radix number 4. Then it's 4, because 4 multiply 56 plus 3, right? Then 3 is remainder. After that, 4 multiply 14, right? And remainder is 0. 4 multiply 3 plus 2, right? 2 is remainder. Okay, become this one. And after that, is 0, right? If you 4, right? Multiply 0 plus 3. Okay. If you continue to do this one, it's maybe 4 and then what? 0, right? And remainder is 0. Okay. If you continue to do this one, it's 4, 0, 0, and so on. Anyway, how about the answer? Okay. First thing that you should remember, the first remainder that you get from this method, it is this one. Remember that be near to the Radix point. Okay, this one is the first one, and the next one is 0, 2, 3. If you continue to calculate, you will have 0, 0 at here. It's okay, right? Because the same value. Okay, its value not change. It's okay. Okay, be careful. If you be not careful, your answer may be something like this: 3, 0, 2, 3. It's not okay, right? Not okay. So be careful. You just remember the first result or the first remainder is the number at the next position from the Radix point. Okay, now how about this? If I want to convert this 0.0 something again to Radix 4. Okay, let's see our objective. You should write in this form, namely some coefficient that may be 0, 1, 2, and 3, right? Multiply 4 to the power of minus 1 plus some coefficient that can be already 0, 1, 2, 3, multiply 4 to the power of minus 2, and so on. Okay, if you can really write in this form, that means your answer is just bring, right, this coefficient, okay, write down together, and don't forget to write Radix point. Okay, for example, this one. For this one, I multiply and divide it by 4. Totally is 1, right? So the value itself not change. Okay, and what? I keep this one because I want to write in this form. That means I multiply 4 to this number. Then it become 1.125. And I separate to the part integer and some fraction. So it's 1 plus 0.125. And then I multiply out. Then it becomes 1 multiplied 4 to the power of minus 1 plus this fraction multiplied 4 to the power of minus 1. This one is okay, right? Okay, this coefficient is already okay, but this one not okay. Then from this one, I multiply and divide it by 4 again and keep this one, because when I multiply to this 4 to the power of minus 1, then it becomes 4 to the power of minus 2. Okay? Yeah. Then I calculate this. Then it becomes 0.5. Then I separate to 0 plus 0.5. Again, multiply out, then it becomes 0 multiply 4 to the power of minus 5, sorry, minus 2 and plus 0.5. Multiply 4 to the minus 2. Okay, this coefficient is okay, this coefficient is okay, but this one still be not. Again, I multiply and divide by 4. Now it's become 2. And then when I multiply 4 to the power of 2 to this one, then it's become 4 to the power of minus 3. Now it's okay, right? 1, 0, 2. Okay, 4 to the power of minus 1, minus 2, and minus 3. Okay, then just take this coefficient, right? Write it down together, and don't forget to add this dot. Okay, so get this result as the answer. Okay, it's easy, right? Easy, but very long, right? Very long to derive this one. So what should you do? Of course, you can do something like this. If observe that this result is come from what? First of all, this one is from this way, this integer, right? Okay, that come from 4 multiplied by 4, right? Okay, become this. The next digit is 1, right? And the next digit is this one. So you can do by using this method. Okay, successive multiplication by Radix number. For example, 4 multiply this, it become 1 dot. Then you remove this integer, then it become 0.125. After that you multiply by 4, then it becomes 0.5. Then you bring this integer part to this one, and then multiply 4 again, then it becomes 2.0, then it becomes 2. Now after you remove this one, it becomes 0. Okay, then you multiply 4 again, and it becomes 0. Of course, you can multiply 4 again and again. How about the result? Again, the first digit and the first number that you get from this method is the digit that is next, okay, on the right hand side from the radix point. This one, right? And this is 0, and this one is 2. If you continue to multiply by 4, the result may be 0, 0, 0, 0. Of course, it's okay because it's the same value, right? Okay, now if I want to calculate this one, what should you do? It's not only integer, it's not fraction that less than 1. What should you do? How to calculate for this? Yes, okay, you can separate two integer plus some fraction, right? And you use successive division for this part and successive multiplication for this part. So for this part, you get what? You get the answer with 3203, right? For this part is 3203 base 4, right? And for this part is 0.102, right? Base 4. When you add together, when you combine together, that means your answer is 3203.102. Okay, base 4. That's all. Very easy. Okay, and how about if I want to convert radix 2 to radix 8? Okay. Of course, now you know how to convert decimal to radix r, right? And you know how to convert radix r to radix 10, right? That means now you can convert any radix x to radix y, right? By convert to radix 10 or decimal first, and then convert to radix y. Okay, easy. By the way, for some special case, for example, if you want to convert radix 2 to radix 8, you need to convert to radix 10 first, okay? And then convert to radix 8. Actually, you can convert from radix 2 to radix 8 directly by using this. At first, for radix 8, each position of this radix 8, okay, the number in this position can be 0, right? 1, 2, 3, 4, 5, 6, and 7, right? Actually, if you compare the binary number for the value of 0, you can write that 0, 0, 0, and 1 as 0, 0, 1, and 2 is 0, 1, 0, 3 is 0, 1, 1, 4 is 1, 0, 0, 5 is 1, 0, 1, 6 is 1, 1, 0, and 7 is 1, 1, 1. Oh, okay. Oh, it's full, right? It's full, right? Okay, for this 3-bit, start from 0, 0, 0 and finish at 1, 1, 1. Okay, so it's perfect fit, right? That means one digit of radix 8 is the same as 3-bit for binary or radix 2. That means you can convert directly between each digit in radix 8 to 3-bit of radix 2. For example, if you want to convert this one, you want to convert this value, that means you just consider this one as 3-bit of binary number. 7 is 111, right? 4 is 100, 5 is 101, 2 is 010. That's all. Very easy, right? You need not to convert to radix 10 first and then convert to binary. It takes time. On this one, for example, 4, 1, 2, 5, 6, 7, 4, 3, 0, 1. Okay, average 8. If we want to convert to binary or radix 2, what should I do? If you convert to radix 10 first, oh, a lot, right? A lot number, a lot. Step to calculate. Anyway, if you want to convert to binary or radix 2, it's easily. You can convert directly. One digit in radix 8 equal to 3-bit in binary. Namely, you can convert directly, digit by digit. Then it becomes 001. For this one, 000. The 3 is 011, and the 4 is 100. 7 is 111, 6 is 110, 5 is 101, 2 is 010, 1 is 001, and 4 is 100. Finish. Right, finish. Finish with very short period. Okay, but if you convert by using the method that convert to decimal first and then convert to binary, maybe you use the time more than 10 minutes. So please try, okay, to use using this method. That means for this method, you must remember how to convert each digit, which may be in decimal, okay, to binary number. Okay. And similarly, if I want to convert binary to radix 8. What should you do? Okay, yes, can do it. For example, 11011011101 dot something 1101111110001. Okay, in binary. If I want to write down in radix, what should I do? Of course, you can starting by convert this 3 bit, add 1 digit of radix 8. Okay, and to do this one, let's check this radix point. Okay, you should refer this radix point. Okay, for starting your calculation. Okay, I group this one with 3 bit. How about this? 1 2, you can add 0, right? As right here, because it still be the same value. How about this? 3 3 3, okay, 3. Okay, if not, you can add 0 on the right hand side. Okay, now can you convert? 101 is 5, right? 011 is 3 3 and 3. For this one, 6 1106 1106 001 is 1. That's all. Okay, you can convert binary to radix 8 easily. Okay, similarly, if you want to convert between radix 16 or hexadecimal to radix 2, can you? Yes, 1 digit of radix 16 equal to 4 bit, right? 4 bit of binary number, because for radix 16 it's 0 1 2 3 until 15, right? Okay, it's actually the same for 4 bit of binary number 000 001 010 until 1111. That means you can convert directly digit by digit. Okay, 1 digit of hexadecimal convert directly to 4 bit, okay, of binary number. For example, if you want to convert, for example, a b dot cd, for example, in hexadecimal, yes, you can convert directly, right? A is 1010, okay, b is 1011, then dot, okay, c is 1100, d is 1101. That finished easily. Or if you want to convert from binary to hexadecimal also, you just group, right? Just group 4 bit, and then you can convert back to hexadecimal. Okay, for example, for this one, this one is to be radix 8. Okay, yeah, for radix 8, for the example, if I want to convert this binary number to radix 8, okay, I just group it, right? Group this one, 3 bit, when just 2, then you can add 0, because it still be the same value, right? This one, be careful, you must convert 3 bit. If not, you can add more 2 bit, okay, to set in 3 bit. After that, you just convert directly for each 3 bit group. That means let's start from this radix point. This one is 2, right? This is 7, this one is 2, this one is 5, and this 011 is 3, 100 is 4. Okay, that's all, very easy. And next one, that example that you want to convert, for example, this radix 2 to hexadecimal. You use 4 bit for each group. Not enough, then you can add 0, 0, 0. For this one, and if not 4, then you can add 0, 0. So then you can convert directly. 1, 0, 1, 0 is 10, right? Then it's A, right? And this one, 11, that is B, right? It's this one, dot. What about this one? This one is B, right? 0, 1, 0, 0 is 4. That's all. For already 16. Easy, right? Yes, pretty easy. Okay. Then this page just shows some conclusion. How to convert between decimal or radix 10, okay, to any radix R, okay, or to radix 8 or 16 or radix 2, and you can convert between radix 8, radix 2, radix 14 directly. Okay. Well, one more example. If I want to convert, for example, 3245.546738 to radix 16, what should I do? If you convert to 10 first and then convert to 16, this may take time a lot. So let you convert to binary first, or radix 2 first, and then convert to 16. So for example, for this one, you can convert directly like 5, okay, into 2, because it's radix 8, right? Then you just change one digit of radix 8 to 3 bit of radix 2. So it become 101 3 bit, right? Then it's 100 3 bit, right? 2 is 010 3 bit, 3 is 011, okay? And for 5, this one 101, 4 is 100, 6 is 110, 7 is 111, right? Okay, after that, if you want to convert to radix 16, you just group with 4 bit, right? 4 bit. This one, right? Group this one, 4 bit. 1, 2, 3, 4, 1, 2, 3, 4. Okay. This one is what? 0, 1, 0, 1, it's 5. 1, 0, 1, 0 is A, right? And 0, 1, 1, 0 is 6. Okay. Dot. What? This is 1, 0, 1, 0 is B, right? And this one is 3, right? And this one is 7. That's all. Finish. Okay. It's faster than you convert to radix 10 or decimal first. Okay. And now, if you want to do addition or subtraction of radix number R, okay, you can do it like decimal number. Namely, for example, in decimal number, if you want to add 15 and 35 and 16. So when you add the indicator, it is what? It's 11, right? But this one you can look it as 10 plus 1, right? And you move this 10 to the next digit. And this 10 then it become 1, right? You call it as carry, right? Carry, okay? It's carry in, right? It's 10, so that means then it become 1 right here, and carry is 1. When you add 3 to this one and then carry in 1, then it become 5. so it's 51. Okay, or if you want to do the subtraction, 35 minus 16. Okay, you can not do 5 minus 6 directly. If you borrow, right? Borrow 10 from this digit, right? Okay, then it's be from this one, then the value decay to 2 because it's borrowed by this digit. Then digit it become what? 15 minus 6, then it become 9, right? And then for this one, the left number is 2, right? 2 minus 1 is 1. Okay. For another Radix number also can do something like this. By consider that for the digit or for the left digit and the right digit, okay, which be at the next position. For example, if this position have the weight at r to the power of k, the next digit, okay, the weight is r to the power of k plus 1, right? Okay, if you want to move, for example, move the digit, for example, from this one to this one, from left to right, okay, move this one to this one, so it's become 1 multiply r to the power of k plus 1, right? Anyway, because the digit weight is r to the power of k, that means you must, okay, change this one to the power of k also. Then it become what? It become r, right? It become r multiply r to the power of k. Note this one in the left digit. When you move to right digit, okay, it's change to r. Okay, one at the digit. Okay, when you move to the right position, okay, the next digit in the right hand side, then its value is r. Okay, refer to this position. Okay, or if you have number with r, when you move to the left hand, then it change to 1. Okay, based on you use it as carry or borrow. For example, okay, consider this one. Okay, 2 plus 3, 2 plus t, 5, right? But because of Radix 4, you cannot write 5 here, right? Because Radix 4, the number that can write in each digit is 0, 1, 2, and 3 only, right? So if the result is 5, you should do something like this. It's 4 plus 1, right? And 4 in the digit, okay? When you move to the next digit, it's become 1, okay? And for this digit, it left only this one. After that, when you do plus 1 plus 2 plus carry in, so it becomes 4, right? But it cannot be 4 at digit. Then you move this 4 to the next digit, then become 1. And for this person is 0. After that, 1, 2, 1 is 4 again, then 4 is 0, and carry in is 1. Okay. Okay, that's all. Okay. What that you should know is carry out and carry in. For when you add it, if there's some carry out, namely this one, okay, say that carry out is 1, carry out of the digit will be carried in for the next digit on the left hand side. How about this? When you do subtraction, okay, 212 minus 123, 2 minus 3, 2 less than 3, right? You cannot do subtraction directly. So you must borrow, right? Borrow from the digit 1 at the digit because of Radix 4. So when you move this 1 to the digit, then it's become 4. So 2 and 4 is 6, right? 6 minus 3 is 3. And the digit now is left 0, right? 0 minus 2, you cannot minus, right? So you borrow 1 from the digit to the digit, then it becomes 4. 4 minus 2, then is 2. Okay? And the digit now is left 1, right? 1 minus 1 is 0. Okay? And what you should know for the subtraction is borrow, right? Borrow in and borrow out. If the digit borrow from the left digit, borrow out will be 1. Okay? And this borrow out will be borrow in for the next digit. And so on. Okay, now let's do something about this. If I want to do addition, okay, 1-bit binary addition, namely 0 and 0. 1 bit add together, the result is 0. Okay, and how about carry out? No carry out. This is sum, right? The result is sum. Okay, 0 plus 1 is 1. No carry out. 1 plus 0 is 1. No carry out. 1 plus 1 is 2. No. You cannot write 2, right? Then it's 0, right? And 1 carry out. Okay? Okay, yes. So, this is the result, right? And carry out. 0 plus 0 is 0. No carry out. 0 plus 1 is 1. No carry out. 1 plus 0 is 1. No carry out. 1 plus 1 is 0. And 1 carry out. Now, if I want to design the circuit, what should I do? If you can observe this result 0, 1, 1, 0 related with input AB is XOR function, right? XOR function. Yes. So you can write R as A XOR B. How about carry out? It's 1 when AB is 1, 1, right? So it's AND, right? C, okay, carry out is A and B. So now you can design 1-bit binary addition by using this. A, B, XOR together. Okay. And what? And C, B, and together. Then you get carry out. This one is result of addition. Okay. So now you can create a circuit. Okay, easily. How about this one? How about subtraction? Subtraction. For example, if you want to subtract 0 minus 0, okay, is 0, right? No borrow, right? No borrow. This one is borrow. No borrow out. 0 minus 1, yes, it must borrow, right? Then it's become 1 and borrow, right? 1 minus 0 is 1, right? No borrow out. 1 minus 1 is 0. No borrow out. Okay? The borrow have only one case, right? 0 minus 1. So when you write in this table, it becomes 0 minus 0 is 0. No borrow out. 0 minus 1 is 1. And 1 borrow out. 1 minus 0 is 1. No borrow out. 1 minus 1 is 0. No borrow out. Again, if I observe this one related with AB, oh, it's XOR function again, right? 0, 1, 1, 0. Then R is A XOR B. How about borrow out? It's 1 at here, right? 0 at here, 1 at here. It cannot A and B, right? In this case, because borrow out will be 1, A must be 0 at here, right? But B is 1. Okay, then you can invert at here, right? So borrow out, then it becomes A invert and B. Because A is 0 right here, right? When you invert, then it becomes 1. right? That is 1 and 1. Okay, 1 is from invert of 0. So you can write down equation for borrow out and R. That means you can write down the circuit diagram, right? Namely, A, B, XOR together. Then you get result of subtraction R. And then for borrow out, invert, right? Invert A and then and B. Then you get borrow out. Okay, so now you can design the circuit for subtraction and addition. Okay, it's quite simple one. Namely, if you want to design something, you should write down, okay, the mathematical expression like this. Like like this, okay, or this, or this. Okay, you can write down equation. Then you can draw the circuit diagram. Then you can implement, okay, the circuit completely. Okay, that's all for today.